Okay, so it's going to be 6-minute miles times the total number of miles she ran divided by 2. Because remember, when she was heading north at 6 minutes per mile, she ran the same number of miles as she did running south at 7 minutes per mile. So each of these distances is her total number of miles run divided by 2. So each of them represents 1/2 of her total distance traveled. So I take her speed times half the number of miles plus her speed coming back times half the number of miles. And that has to be equal to the total number of times she spent out running, which was 47 minutes. Because I know she started at 6 and ended at 6:47. Okay, so I can go ahead and put these fractions together because it's, let me rewrite it. So it's going to be 6x divided by 2 plus 7x divided by 2 equals 47. I recognize that these are the same denominator. So this becomes 13x divided by 2 is equal to the amount of time it took her to run, which was 47 minutes. Now I'm just solving for x. So when I'm solving for x, I'm going to multiply the 2 over, and I get 13x is equal. 47 times 2 is 94. I go ahead and divide both sides by 13, and I get x is equal to 7.23 miles. So in total, this woman ran 7.23 miles, half of which she ran due north and half of which she ran due south. Problem number 6, it gave us an equation for calculating the air temperature given certain information like the ground temperature and the altitude. So part A is telling us to determine the air temperature T at a height of 1 mile if the ground temperature is 70. So what I did is I took that equation it gave us and I put in 70 for the ground temperature because that's not going to change. It wants us to solve at a height of 1 mile. Well, this tells me that my height is actually measured in feet for this equation. So how many feet are in 1 mile? Hopefully you know it's 5,280 feet. And I can just go ahead and plug this into my calculator. And I get T is equal to 40.96 degrees Fahrenheit. We're going to kind of use the same process for part B, except we're going to go the other direction. Okay, so in part B, still using ground temperature of 70, it wants us to find the altitude or the height where the temperature is equal to freezing. So I have to know, okay, what temperature in Fahrenheit is freezing? Well, I know that's 32. I know the ground temperature is still 70, and this is unchanging. So now I'm just going to solve for H. So I'm going to show you the process that I would use for this. So the first thing I would do is I would go ahead and subtract this 70 over. So when I do that, I get a negative 38 is equal to a negative of 5.5H, all divided by 1,000. So I just put the H in the numerator with the 5.5. I can go ahead and multiply the 1,000 over, which gives me negative 38,000 equals negative 5.5H. Divide each side by negative 5.5, and we get H is equal to 6909.1 feet. And then we're finished. Our last question is question number 7, and it says archaeologists can determine the height of a human without having a complete skeleton. So it says that we can just take the length of the humerus and plug it into these respective equations and solve for their height. So here's the equation for a woman, and then here's the equation for a man. Part A is dealing with a woman, so we're going to be using the H equals 65 plus 3.14 times the length of the humerus in centimeters. And it's saying they found a female skeleton that has a 30 centimeter humerus. What's the woman's height? So I'm just going to take 30